Welcome. In this video, we are going to discuss the resonance condition of RLC series circuit. Here I drawn one graph and written some equations. Let me start with the impedance equation of RLC series circuit. So Z equal to root of R square plus XL minus XC square. This is the impedance equation of RLC series circuit. So now just imagine one condition. At this condition, the value of inductive reactance equals to the capacitive reactance. That means XL value is equal to XC. At this condition, XL value is equal to XC means XL minus XC becomes 0. So that means the net reactance value becomes 0. XL equal to XC condition. So at this condition, so this term becomes 0 means only remains root of R square. So root of R square is equal to R. So Z equal to R at this condition. Z equal to the impedance means the opposition offered to the flow of alternating current is only by resistance, not by inductor and the capacitor, because they are cancels each other. Reactances are 0. So only remains resistance only. So Z equal to R. So current also at this condition the current equal to I equal to V by Z. Here Z means R. So V by R only. The current equal to V by R only at this condition. So Z equal to R means just inserted instead of Z R. So I equal to V by R at this condition. So at this condition XL equal to XC means this condition is known as resonance condition. So resonance condition XL equal to XC, the series circuit. So same current is flowing through the inductor and the capacitor. So we can say VL equal to VC. VL equal to I into XL equal to I into XC. Both are same voltages but opposite direction. So just remember, in this condition the magnitude of the voltages induced in the inductor and the capacitor may be greater than the supplied voltage. So that's our important point. The magnitude of the voltages in the inductor or in the capacitor is greater than the supply voltage. So in this condition I equal to XL or I equal to XC. So and both are cancels each other. So suppose we are drawing the vector diagram. So VR voltage across resistor and this one is voltage across inductor. This one is a voltage across capacitor. This is a reference I. Based on the I, the current voltage is leading in the inductor and voltage is lagging in the capacitor. So here VL and VC are same magnitude but opposite in direction. So cancels each other. These are cancels each other. So net voltage or total voltage is equal to only VR. So applied voltage or net voltage is only VR, or else V equal to VR plus VL plus VC actually. But here only VR, VL and VC are cancels each other. So net voltage only V equal to VR only, voltage across resistance only. So next, same using the same condition XL equal to XC, we can find out the frequency at what frequency this becomes equal. Clear? So here XL equal to XC, XL equal to we know that omega L or 2 pi FL, or XC equal to 1 by omega C or 1 by 2 pi FC. So here I am taking omega, here L is numerator, goes to right hand side denominator, and here denominator omega taking left hand side means goes to numerator. So omega is omega square equal to 1 by LC. Here omega means 2 pi FL, not 2 L, 2 pi F, omega is 2 pi F square. Here I am taking only taking F square and 2 pi is numerator 2 pi, I am taking right hand side denominator. So F square equal to 1 by into divided by 2 pi square into LC. Here square, so square taking out means this becomes root, this side becomes root. So inside the root 2 pi square means taking outside only becomes 2 pi and 1 and LC becomes root LC. So frequency equal to 1 by 2 pi root LC. At this condition, what is the frequency means 1 by 2 pi root LC. So this frequency is known as reference frequency or resonance frequency. So resonance frequency Fr equal to 1 by 2 pi root LC. We can find out at what condition the circuit may be resonance. And the problem also, suppose the problem is given, the resonance condition means, suppose we know only one value, suppose we know only capacitor value, we can find out XL value because we can write XL equal to XC. From this side we know because capacitor value we know, so we can find out the inductor value also, and the vice versa also. If you know the inductor value, we can find the capacitor value also. Suppose we know the frequency and the any one value, we can find out the other value also. And again, based on these conditions, we can draw one graph also. The graphical representation is can understand easily. So here XL equal to, we know that XL equal to 2 pi FL and XC equal to 1 by 2 pi FC. So here I taken the x-axis is frequency. So whenever frequency increases, here frequency is 0, frequency 0 and increasing. So whenever frequency increasing, XL value also increasing directly or linearly. So this one, this line is represents the XL. Whenever frequency increases, 2 pi frequency into L. So this increases directly. So this value belongs to XL. This line belongs to XL. And here X equal to 1 by 2 pi FC. So in the initial condition, very low value means 1 by very low value means it may be infinity value. I am taking in the downside because of its XC is lagging conditions. I am taking downside. So it may be infinity condition. Whenever frequency increases, the value also decreases. So this line belongs for XC. Frequency is very low means very large value. Again frequency increases means it is nearer to 0 value. Clear? So both are depends upon frequency. We can draw two lines. It's a XC, this is a XL. Now based on XL and XC, I drawn one dotted line. This one is for XL minus XC line. Clear? In this case, X is very large, so very large value. Again, XL is increasing, so difference also decreasing. At one position, here the value of the XC and the value of the XL is equal at one position. XL value and XC value is equal, that condition here. This point the XL equal to XC is 0. XL equal to XC is 0 condition. Clear? At this condition, what is other values? So here I drawn one yellow color line, that is our resistance. Resistance is not depends on frequency. Resistance is resistance only. It's a fixed constant value. So I drawn one constant line. This is belongs for resistance. Clear? So here this line, parabolic line, belongs for Z. Initially Z equal to root of R square plus XL minus XC. So X is large value, it's a smaller value, but totally larger value. So Z also large. Again the difference is decreases. This value decreases means the Z also decreases. At one condition, XL equal to XC, that part is 0 value, the Z equal to only R. Here Z equal to R condition. Z equal to R. At this condition, Z equal to R. Clear? So we drawn XC, XL and the difference and the resistance and the impedance line. So at this condition, I dotted line one indicated here. So at this condition, what is the frequency? At what frequency this happened? The frequency is known as FR, resonance frequency. At resonance frequency, XL becomes XC and Z becomes R. At this condition, the maximum current also appeared, because here opposition means only resistance, not the inductive reactance. Also there is zero, no, cancel each other, so only resistance. So maximum current is appears at this condition. So I can draw one more line here. So initially current is 0, so current is increases. At this position maximum current again decreases. So at this condition V equal to, no, I equal to V by R. At this condition maximum current is appears. So this is totally, we can say, resonance condition of RLC circuit. So we started with impedance equation. So in the impedance equation, resonance occurs means the XL value equal to XC value. At this condition, what happens in the other values we discussed. So once again we can recap again. VL equal to VC in this equation. So both are cancels each other. So only applied voltage appears across, only resistance, only the voltage of across inductor and the capacitor may be the greater than supplied voltage also, but opposite each other, cancels, only remains V equal to VR. And using the same equation XL equal to XC, we found the watt frequency. At what frequency the resonance happens. So that frequency is called as FR. FR equal to 1 by 2 pi root LC. And based on all these value, we drawn the graph. Here XL equal to 2 pi FL and XC equal to 1 by 2 pi FC. Based on frequency increasing, we drawn two lines XL and XC, and the difference also we drawn. So at one condition, at resonance frequency, it becomes equal and the Z equal to R. So at this condition, current also maximum magnitude. So this is a resonance of RLC series circuit. So in the problems they mentioned the resonance condition means just take XL equal to XC and find out vice versa values, capacitor value or the inductor value, or given the total value means find out the rest of the things, current, voltage, etc. This is a resonance of RLC series circuit.